Okay, here we are, lesson 9.6, graphing parabolas, and this is the last lesson of the book. And one of the things that we've done is we've used these little tables here, and when we're given something like x plus 1 equals y, we would put in a number for x, like 2, and when we add 2 and 1, we'd get 3, and our y would be 3. And we could just do that over and over and over with lots of different numbers, and then we could graph. We'd put all those points on, so there's like 2, 3 there, and let's say this is x is 3, y would be 4, so 1, 2, 3, 1, 2, 3. We'd end up getting a line like that. This is called a linear equation because when we graph it, it gives us a straight line. And it gives us a straight line because the exponent on the x is 1, even though it doesn't show up, there's an assumed 1, and the exponent on the y is again an assumed 1. So when the exponents on the x and y are 1s, you get a straight line. This section talks about what happens when one of those variables is not a 1. So for example, if we have the equation real simple, and that's got a squared on it, okay? When we do our little x and y, we get something totally different. So let's say that this is our x and this is our y. So if our x is 2 and we square it, our y is 4. If our x is negative 2, what happens when we square a negative 2? Two negatives give us a positive. 2 times 2 is 4. If we use 0, 0 times 0 is 0. If we use 3, 3 times 3 is 9. If we use a negative 3, we also get 9. So what happens when we graph this, and let me get a graph up here for us. There we go. And we graph what's there, and we'll do it in blue. So 2, 4, negative 2, 4, 0, 0, 3, 9, negative 3, 9. Gives us, if we draw a line here and we kind of make our curves kind of fit that a little bit and be smooth, that is called a parabola. Okay? Now a parabola does one of two things. It either opens up and would hold water, or it could open down and dump water. Okay, so those are your two options. A couple things about a parabola. This right here is called the vertex, and that's also called the vertex. It's either the lowest part of the parabola or the highest part, and it goes down on either side or it goes up on either side. Okay, so that's what happens when you have, on your variable, instead of having a 1 there, you have a 2. Okay, and it's squared. All right, so that is in that form with a 2 on your variable gives you a parabola. And I'm just trying to look ahead at the book. Example 1 gives us, and we're not going to go into a lot of detail here, though you can really get carried away and crazy with parabolas, but we're not going to do that here. So right there we've got our y equals x squared minus 3. So what I like to do is write that, and then I like to write the equation, just to remind me of what I'm doing, and then my y. Okay? So if my x is 0, and I plug 0 in for x, I get negative 3, 0 minus 3. If I were to use negative 2, I'd have negative 2 minus 3, which that means negative 2 times 2 is 4, 4 minus 3 is 1. If I use a positive 2, y equals 2 squared minus 3, which is also 1. Okay, so you keep going along that line of plugging in a bunch of numbers. I usually like to have students do this. If you put the negatives a number in, put the positive in. Okay, so you've got the same number in, and see what you get here. It should be the same. So I usually like to try 5 numbers because that kind of gives me an idea of what's going to go on with this graph. So let's plug in 0, negative 3. Gives me a point there. Negative 2, 1. Gives me a point there. And 2, 1 gives me a point there. So it kind of gives me an idea of what this parabola is going to do. Although I like to have 5 points, so 2 more, just to kind of tell me what's going on up here and up here. Okay, so I'd probably put in for x negative 3 or positive 3 or maybe even 4 to find out what's going to happen if this actually does go up that way. Okay, so that's one method of doing it. Now if you look on page 627, you've got example 2, and bottom of page 627 you have example 3, and basically it's the exact same thing. We're just making that xy graph. So like example 3, y equals the quantity x plus 2 squared minus 3. Now see, the squared sign is on there, so I know I'm going to get a parabola. Alright, so I've got a y there. So let's say that I put in a negative 4 for x. I'm going to get y equals negative 4 plus 2, quantity squared minus 3. Negative 4 plus 2 is negative 2 squared is positive 4 minus 3 is going to give me a 1 here. And this is a different equation, I guess, than example 3. I wrote it down wrong, but it doesn't really matter. We put a 0 in, and we get 0 plus 2 squared minus 3, which means 0 plus 2 is 2, squared is 4, minus 3 is 1. And if we put in a 2, y equals 2 plus 2, quantity squared minus 3 would be 4, 16 minus 3 is 11. So see, you're getting just a whole bunch of numbers that you can go ahead and graph and get a parabola there. Alright, so that's one method of doing these. Example 4 is the same way. You're just plugging numbers in, any numbers you want for x, and it will spit out a y value so that you can graph it. And we've done this, long time. But let's see what happens if we decide, like most algebra, you learn one way of doing it and then you find out later there's actually an easier way to do it, and the same is true here. If we want to find out a couple points, relatively easy, what we do is we look for what are called the intercepts. Intercepts are where the line, or the parabola in this case, crosses either the y-axis or the x-axis or both. It's where it intersects, it crosses. So that's what I'm going to be doing here, is looking for a chance to find those points where the parabola crosses the graph somewhere. Okay, so let's look at example number 5. And it gives us the equation y equals x squared minus 6x plus 5. And we want to find the intercepts. Alright, we want to find if so where the parabola crosses this line, the y-axis, or the x-axis. Okay, we're going to look for both of those. So what we do is, if we want to find out where it crosses the x-axis or the x-intercepts, we make y equal to 0. Okay, and we just solve it. Okay, there's 6x plus 5. So we can use a quadratic formula, or we can first of all try to factor this. So factoring means this. Factoring it into two binomials, and we find out two numbers multiplied together give us 5, added give us negative 6, so it gives us that. So we set that equal to 0, and we set the x minus 5 equals 0, and we find out that x equals 1 or x equals 5. Those two numbers that we get here are where the graph crosses the x-axis, at 1 and at 5. Okay? Now let's say we want to find out where the parabola crosses the y-axis. So we're going to erase all this work here where we found out where it crosses the x-axis. And what we're going to do now is we're going to put a 0 in for x instead of y. This is the one that's a bit easier to solve. So y equals 0 minus 0 plus 5. So it crosses the y-axis at 5. Okay, so that gives us a little bit of an idea of what the graph looks like. Now in this particular one, they just wanted to find the intercepts. Where does it cross? They didn't necessarily want you to make a drawing. But what happens here, the way that parabolas work, is you kind of get an idea that it's going to open up and it's going to come down here like this somewhere. We don't know exactly where the vertex is here, but we're not being asked to draw it, so it doesn't really matter. All we are being asked to do is find the intercepts. The y-intercept is 5, the x-intercept was 1 and 5. And one of the things that's important to understand is when you find a y-intercept, where this is going to cross the y-axis, it can only cross it at one place. I mean, if we draw a parabola, it doesn't matter where we draw it. Notice it's only crossing that y-axis once. Okay? Now, if it were sideways, like this, it would cross it twice, but that's no longer a parabola. Parabolas only go up or down. So it will only cross the y-axis at one place. So if you get two y-intercepts, did something wrong. Alright, so let's try another one. Example number 6. And we get y equals x plus 1, the quantity squared, minus 3. Alright, so what did I say? If we're looking for where it crosses the x-axis, we're going to put 0 in for y and then solve for x. Now, let's move this over. And remember, when it's squared like that, you take the square root and put a plus or minus there. So we get plus or minus square root of 3 equals x plus 1, or negative 1 plus or minus square root of 3 equals x. I subtracted 1 from both sides. Okay, now that's kind of a mess, isn't it? That's where it crosses the x-axis. So what you're going to do is you're going to take your calculator and you're going to find out what the square root of 3 is. And you will find out that it's 1.7. Okay, and so what does this mean? It means negative 1 plus 1.7 or negative 1 minus 1.7. And that's going to be our x values. So negative 1 plus 1.7 is going to be 0.7. Negative 1 minus 1.7 is negative 2.7. So that's where it's going to cross. Okay, so you're just kind of guessing here when you're graphing that it's going to cross at 0.7, which is around there, around 3/4, and it's also going to cross around there at negative 2.7. Okay, but again, we're not asking to graph. We are just looking for the intercepts there. Okay, so now I'm going to go ahead and erase all this and rewrite the problem up here. Is y equals x plus 1, the quantity squared, minus 3. Now this time we're going to put 0 in for x, because that's going to tell us where it's going to cross the y-axis. And this is the easy one. So 1 squared minus 3, or 1 minus 3 equals negative 2. So it's going to cross the y-axis at -2 right there. Okay, so that gives us that point of intersection of the y-axis. Okay, so this is example 7 on page 630, and this is going to be done a little bit different, kind of, because again, you're trying to find out where it crosses the x-axis, so we have to set our y value equal to 0. So I'm going to flip these around. Oops. This does not factor into two binomials. There's not two numbers multiplied together that give you 5 and added that give you 2, because you just have 5 and 1. So that means you're going to have to use the quadratic formula. If you remember what it is, I'm trying to talk and write it down at the same time. Makes it a little bit harder. And then I get my arm on the screen and it makes it whipper-jawed. Alright, so there we go. So let's say we put a negative b, so that's -2 plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay, so we solve this. I'm going to assume that you can either look at the book or solve it on your own, and we find out that x equals -1 plus or minus the square root of 6. So that means it crosses the x-axis at -1 plus the square root of 6 and -1 minus the square root of 6. So you have to take your calculator, find the square root of 6, and we find out the square root of 6 is about 2.4. Okay, so let's try this again. -1 plus 2.4, -1 minus 2.4. Alright, so that means that it crosses the x-axis at 1.4 and -3.4. Okay, so again, 1.4 is around 1.5, -3.4 is around 3.5, so we're kind of guessing there. And that gives us that point. If we want to find out where it crosses the y-axis, then we would have to take our original equation here, and let's kind of move stuff out of the way here. And let's do it in blue. We'll put y equals 0 plus 2 times 0 minus 5, so which gives me y equals -5. So that's where it crosses the y-axis there. Okay, so we have our -3.4 and we have our 1.4. Kind of get an idea then that this is going to look a little bit like that. Okay, notice my vertex is kind of over a little bit, but what you do in order to find out exactly what that parabola looks like is you graph that point, you graph that point, and you graph this one, but you also have to throw a couple other numbers. Remember how at the beginning we had an x and a y? Okay, and I said it'd be good to have 5 points. Well, we have 3, so you're going to have to throw another couple points in here in order to find some of the other points. So let's say that we threw a -1 in here. So in here we would have a -1 squared plus 2 times -1 minus 5. So that'd be 1 minus 2 minus 5. So 1 minus 2 is -1 minus 5 is -6. So that would give us this point here. So I've kind of got it a little off, don't I? So let's use my blue again and make this come down more that way. See how the parabola looks so much different once I start putting in other numbers and getting other points in here. to find out different places this parabola goes. Like I had it coming only to right here, and it really comes all the way down here once I started putting numbers in. So anyway, that is lesson 9.6, the last lesson of the book, and not too terribly difficult, just some new stuff there.